This is a short summary of how you can assess how good question items are and exams are within RadExam. So we always look at item statistics, and we routinely gather a number of different statistics about all question items within RadExam. The item difficulty is measured by the p-value. We look at the distributions of the various answer choices by the candidates, and then we look at the discriminatory index. This is called various things. The more formal name of it is the point biserial coefficient. I'm going to go through each of these in turn. So item difficulty basically, is the question too hard or is the question too easy? So that's, I think, pretty obvious. And this is measured by the p-value. And so the p-value is the fraction or the percentage that got the answer right. And ideally, you want it to be between 35 and 95% of candidates answered that question right. And to be able to have reliable statistics, you need generally to have more than 30 deployments. If the p-value is too low, so under 35%, it's basically too hard. So people are scoring incorrectly on it. Now, it may be because there's errors, so it could be keyed wrong. In other words, the correct answer is not been assigned to this question. There may be things like typos, perhaps the image isn't as clear as it should be, or it's just too hard for the particular group that's been tested on. Sometimes we move questions to a higher R level that we think are too hard. Negative questions, in other words, questions that say something like all the following are true except, may often score very low because they're confusing to test takers. So we have a requirement that we only use single positive answer questions. Perhaps the stem's not clear, or perhaps the answers are confusing or overlapping. Conversely, if the p-value is too high, so more than 95%, it's too easy for testers. And so that question is not going to discriminate between the high and low scoring candidates, and it's often considered to be a wasted question. It needs to be made a little tougher. When we're looking at questions during audit, we also look at how the answer choices have been distributed. In other words, what percentage of test takers have selected each answer. And this helps us identify which distractors need editing. So if you have one specific distractor, the distractors are the wrong answers that a lot of candidates have selected. It may be perhaps this was the correct answer and it's been keyed wrong. It may be that there is more than one correct answer. And you want to really have a fairly even distribution across the distractors of the selection. So I'll show you an example on the next slide. So in this particular case, we have a P of 70%. So that's pretty good. The answer is B. 70% of people selected B. And you can see that the other answers, A, C, D, and E, are distributed pretty evenly. So this is a good ideal distribution of question answers. What happens if we're seeing very uneven distractor frequencies? Perhaps the distractors are too similar to the correct answer, or they're completely implausible, so nobody's picking them. Those aren't good distractors. And then sometimes there's things like false cluing, where you're distracting people into picking something inadvertently by the way that you phrased the stem. Let's talk briefly about the discriminatory index, or the point biserial. So the discriminatory index shows how good this particular question is separating out the low and the high performers on that particular exam. So it is exam specific. And it compares the performance of the top and bottom quartiles of students in the exam. In other words, did the the smarter students get this question right, and the less well-achieving students get it wrong, or vice versa. And you want this to be higher than 0.1. The higher it is, the better it is. And negative DI is really bad. Now, to have this be a valid index, you need to have more than 200 deployments of that particular question in that particular exam. So if the DI is low, again, if you're keyed wrong, then obviously this is not going to be a helpful index. Perhaps it's a confusing question, and so the smart testers are really overthinking it. Negative questions often get misread, and so they can sort of direct people to picking a wrong answer and give you low DI, or perhaps sometimes there are too many answer options. Now, you can have good questions that have a lower p-value. So in other words, they're tough questions but have a very high DI. So something like a p of 23% and a DI of 0.4 is an excellent discriminatory question, although it's tough. But a few of those type of questions included in an exam are okay. Conversely, you can have p-values that are okay, but very poor DI values, so like 75% P with a DI of 0.05 is sort of not a good question. It's not distinguishing between the high and the lower performing candidates. So I'm just going to show you an example of how you can find these things within RadExam specifically. Obviously, I've just blurred a couple of things so as not to give all the answers away to folks. So if we look here, what I've done is I've clicked on the image library. And then in the image library, I've picked on a specific exam here. And it's going to come up with a bunch of things. First of all, it's going to show you for the exam some statistics. These exam statistics, not question statistics. The mean discriminator index is a little bit of a bogus value here, but it does give you an idea of how good the questions are overall. The mean exam score, 77%. So again, sort of within the kind of the range that we want. And you can see just a little bar graph here demonstrating what we consider as good and bad values for these. It's going to give you the median score and the standard deviation. It's going to tell you how many times this has been administered. So remember, for DI, you need to have more than 200 administrations. For a good p-value, more than 30, so plenty here. And how many questions are in that particular exam. Now, those were the exam statistics, and now we're looking at the question statistics. So for each individual question within it, it will say how many times it's been administered, which will be the same. It's going to tell you what percentage were correct, the p-value. So we want that, as I said before, between 35 and 95%. And it's going to say the DI, the discriminant index, that you want to be greater than 0.1. Any questions that fall outside of these statistics will be marked with a red bar, and you can actually click on this red bar at the top and it will bring those up so you can see how many there are. And, you know, there's often one or two in exams. You can see these are pretty borderline, so this exam would be fine. If you click on any of the individual questions, it will bring up the individual question statistics in more detail. So this is just repeating what we saw before. It gives a little more detail on things like Bloom's taxonomy level, what R value we assess this question as, and then you will see the question breakdowns here. And you can see for this particular question, which I pretty much randomly picked on, the p-value is 77%. The item spread is kind of okay, but clearly option D is a bit of a throwaway answer, and with a perfect question, those would be more even. So I hope that was helpful to give you an idea of how you can look at exams and assess whether they're good exams, assess whether they're good questions within it. And this helps us a lot when we're doing item audit, which we do within RadExam every couple of years. Thank you very much for listening.